I am deal coordinate system now. Now topic is coordinate system. Start. Now the first problem is if 2 comma 1, 2 comma 5 are opposite corners of a square, then length of its side. Now given 2 comma 1, 2 comma 5 are two opposite vertices or two opposite corners of a square. If suppose taking square 2 comma 1, 2 comma 5 are two opposite corners of a square, it is nothing but two ends of the diagonal, Now the distance between 2 points we get length of the diagonal. Now the distance between 2 points equals to square root of x2 minus x1 whole square or 2 minus 2 whole square plus 5 minus 1 whole square, or that equals to 4. Now length of the diagonal equals to 4 units. Now required length of the side of the square. Now if d is length of the diagonal, length of the side is a, then the relation between a and d, now a equals to d by root 2, or that equals to 4 by root 2 equals to 2 root 2. Then answer is second option. Now next problem. If pi by 2 less than alpha less than pi, then the distance between the points tan alpha comma 2 and 0 comma 1 Now required the distance between the points tan alpha comma 2, 0 comma 1, but given condition pi by 2 less than alpha less than pi, Now the distance between two given points equals to square root of tan alpha minus 0 whole square plus 2 minus 1 whole square, or that equals to square root of tan square alpha plus 1, or that equals to square root of secant square alpha, that equals to mod of secant alpha. But here given alpha lies between pi by 2 and pi, then alpha belongs to second quadrant. In second quadrant secant is negative, then distance equals to minus secant alpha, because secant alpha in second quadrant negative, minus of minus plus, always a distance is positive, then answer is third option. Next problem. The distance of the point x comma y from its image in x axis, Now x axis, y axis, the given point x comma y. Now point to take it is a x comma y. Now the image of the point x comma y with respect to x axis, or it lies in the fourth quadrant. Now consider P be the image of a with respect to x axis. Then the coordinates of the point P x comma minus y. Now require the distance between a and P. Now AP equals to square root of x minus x whole square plus y minus of minus plus y whole square, or that equals to square root of 0 plus 2y whole square or that equals to 2y. 2y. Now answer is second option. Next problem. The midpoints of the sides AB and AC, AB and AC of a triangle ABC are 3, 5, 3, 5, minus 3, minus 3, minus 3, minus 3. Then length of the side BC, required the length of the side BC. Now the triangle ABC, ABC is a triangle. Given the middle points of the sides AB and AC 3, 5, minus 3, minus 3. Now midpoint of AB 3, 5. Next midpoint of AC minus 3, minus 3. Consider P and Q are middle points of the sides AB and AC. Now required length of the side BC, length of the side BC. Now the line segment joining middle points of two sides, the middle points of two sides of a triangle is parallel to third side and half of the third side. Now then BC equals to length of the side BC equals to 2 times to PQ, 2 times to PQ. Now PQ equals to the distance between two given points. Now that equals to square root of 3 plus 3 whole square plus 5 plus 3 whole square. Now that equals to square root of 3 plus 3, 6. 6 whole square equals to 36 plus 64, or that equals to root 100 or 10. Now the distance between PQ equals to 10 units. Then length of the side BC equals to 2 times 2 PQ. Then BC equals to 2 PQ, or 2 into 10 equals to 20. Therefore answer is second option. Next problem. The harmonic conjugate of 4, 1, harmonic conjugate of 4, 1 with respect to the point 3, 2 and minus 1, 6, minus 1, 6. Required the harmonic conjugate of 4, 1 with respect to the line segment joining the points 3, 2 and minus 1, 6. Harmonic conjugate. If suppose A and B are 2 points, A and B are 2 points. Now there is a point P. Point P divides AB in the ratio m is to n internally, m is to n internally, and another point Q divides AB in the same ratio m is to n but externally. Another point Q divides AB in the same ratio m is to n externally. Then the points P and Q, the points P and Q are called harmonic conjugates to each other with respect to the line segment AB. The points P and Q are called harmonic conjugates to each other with respect to the line segment AB. Now consider P as 4, 1, the given next 2 points A and B. A and B. Required the harmonic conjugate of 4, 1 with respect to the line segment AB. With respect to the line segment AB. Then the first, the point P divides AB in the ratio. Take P x, y. A x1, y1, B x2, y2. Now the point P x, y divide the line segment AB in the ratio minus of x1 minus x is to x2 minus x. Minus of x1 minus x is to x2 minus x. Now that equals to minus of 3 minus 4 is to minus 1 minus 4, or that equals to 1 is to minus 5. Then the point P divides AB in the ratio 1 is to minus 5, or the point P divides AB in the ratio 1 is to 5 externally, means that is nothing but here take as P. P divides externally. Now require the point Q which divides AB in the ratio 1 is to 5. 1 is to 5 internally, in the ratio 1 is to 5 internally. Then the coordinates of the point Q, which divides AB in the ratio 1 is to 5 internally is minus 1 plus 15 by 1 plus 5 comma 6 plus 10 by 1 plus 5, or that equals to Q 14 by 6 comma 16 by 6, or that equals to the required point is 7 by 3 comma 8 by 3. Therefore, the harmonic conjugate of P4 comma 1 with respect to the line segment joining the points A3 comma 2 and B minus 1 comma 6 is 7 by 3 comma 8 by 3. Then answer is third option. Next problem. The maximum area of the triangle formed by the points 0, 0, A cos alpha, comma minus B sin alpha, A cos alpha, comma B sin alpha. Required the maximum area of the triangle formed by the given 3 points. The area of the triangle formed by the points 0, 0, A cos alpha, comma minus B sin alpha, A cos alpha, comma B sin alpha. Now, area of the triangle formed by 3 points 0, 0, x1, y1 and x2, y2, and x2, y2 is half into modulus of x1, y2 minus x2, y1 square units. The area of the triangle formed by the points 0, 0, x1, y1 and x2, y2 is half into mod of x1, y2 minus x2, y1. Then that equals to half into modulus of x1, y2 AB sin alpha cos alpha minus x2, y1 minus AB sin alpha cos alpha. Now that equals to half into mod of AB sin alpha cos alpha minus into minus place AB sin alpha cos alpha, that equals to 2AB sin alpha cos alpha, half into mod of 2AB sin alpha cos alpha, or that equals to half into mod of AB into 2 sin alpha cos alpha equals to sin 2 alpha. If sin 2 alpha is maximum, we get maximum area. Sin 2 alpha is maximum, we get maximum area of the triangle. Now, the maximum value of sin theta is 1. When we get now sin 90, theta equals to 90 degrees, sin 90 is maximum, its maximum value is 1. Now, if 2 alpha equals to 90 degrees, we get maximum area of the triangle or maximum value of sine. Now, that equals to, therefore, maximum area equals to of AB. Then, answer is third option, half into mod AB. Half into mod AB. Next problem. An equilateral triangle as each side A, as each side A. If x1 y1, x2 y2, x1 y1, x2 y2 and x3 y3 and x3 y3 are vertices of the triangle, then required x1 y1 1, x2 y2 1, x3 y3 1 whole square value in terms of A, in terms of A. Now, given equilateral triangle, 3 vertices of equilateral triangle x1 y1, x2 y2, x3 y3, x1 y1, x2 y2, x3 y3 are 3 vertices of the triangle and length of its side equals A. If length of the side of the triangle is A units, then area of the triangle delta equals to root 3 by 4 A square. Area of the triangle, area of equilateral triangle equals to root 3 by 4 A square. But given vertices x1 y1, x2 y2 and x3 y3, now that area equals to half into determinant of x1 y1 1, x2 y2 1, x3 y3 1. Now 2 times cancel. Now squaring on both sides, we get determinant of x1 y1 1, x2 y2 1, x3 y3 1 whole square equals to 3 by 4 A square, 3 by 4 A square. Now area of the triangle equals to 3 by 4 A power 4, 3 by 4 A power 4. Now second option, second option. Next problem. The sides of the triangle are y by z plus z by x, comma z by x plus x by y and x by y plus y by z. Then its area in square units. Now given the sides of the triangle y by z plus z by x, comma z by x plus x by y and x by y plus y by z are lengths of the sides of the triangle. Lengths of the sides of the triangle given. If suppose triangle ABC, the length of the side opposite to angle A or length of the side BC equals to small a, length of the side AC, it is opposite side for angle B, it is B, and length of the side AB equals to small c. Now small a, small b, small c are lengths of the sides BC, CA and AB of the triangle. Now S equals to A plus B plus C by 2. S equals to A plus B plus C by 2. Now area of the triangle delta equals to square root of S into S minus A into S minus B into S minus C. Area of the triangle, if lengths of the sides given, area of the triangle delta equals to square root of S into S minus A into S minus B into S minus C. Now here lengths of the sides, first side consider A equals to y by z plus z by x, B equals to z by x plus x by y and C equals to x by y plus y by z. Then S equals to A plus B plus C by 2. Now sum of lengths of the sides by 2, or that equals to, we get y by z plus y by z, 2y by z, next x by y plus x by y, 2x by y plus z by x plus z by x, 2z by x. Then S equals to, we get x by y plus y by z plus z by x. Now area of the triangle delta equals to square root of S. S nothing but x by y plus y by z plus z by x into S minus A. x by y plus y by z plus z by x minus y by z plus z by x. That is nothing but x by y into y by z s minus b. S minus b equals to x by y plus y by z plus z by x minus of z by x plus x by y. That is nothing but y by z. Similarly, s minus c equals to z by x. Now x cancel, y cancel, z cancel. Now area of the triangle equals to square root of x by y plus y by z plus z by x. Now area of the triangle equals to square root of x by y plus y by z plus z by x. It is nothing but second option. Next problem. If the points k comma 2k, 3k comma 3k and 3 comma 1 and 3 comma 1 are collinear, then k equals to, require the value of k. The given 3 points are collinear. 3 points are collinear, then they lie on a same straight line. The same straight line. If suppose the 3 points consider A, B, C, 3 points are collinear or lie on a straight line, then the slope of AB equals to same as slope of BC. The slope of AB equals to same as slope of BC. If suppose the given points consider ABC, ABC are given 3 points. Now slope of AB equals to same as slope of BC. 3 points are collinear, then slope of AB equals to slope of BC. Now slope of AB equals to y2 minus y1 by x2 minus x1, or that equals to slope of BC 1 minus 3k by 3 minus 3k. Now 3k minus 2k equals to k by 2k equals to 1 minus 3k by 3 minus 3k. Now k cancel. Now 1 by 2 equals to 1 minus 3k by 3 minus 3k. Now cross multiply, we get 3 minus 3k equals to 2 minus 6k. 2 minus 6k. Now take k terms one side, remaining other side, we get 3k equals to minus 1. Now k equals to minus 1 by 3. K equals to minus 1 by 3. Second option. Now next problem. If 3 comma 5 with the distances between the parallel sides and 30 degrees with the angle between two adjacent sides of a parallelogram, then its area. Now parallelogram, the distances between parallel sides, (3 and 5), the distances between parallel sides, or shortest distance between the parallel sides 3, 5 given. Now consider D1 and D2 are distance between parallel sides of a parallelogram. D1 and D2 are distances between parallel sides, and angle between two adjacent sides theta. Angle between two adjacent sides theta, but given theta equals to 30 degrees. Theta equals to 30. Now area of the parallelogram equals to d1 d2 by sin theta. D1 d2 by sin theta. Here d1 equals to 3, d2 equals to 5 and theta equals to 30 degrees. Now substitute the values we get 3 into 5 by sin 30 degrees, or that equals to 3 into 5 15 by sin 30 degrees value 1 by 2, that equals to 30 square units. Now area of the parallelogram equals to 30 square units, then option is third answer is correct. Next problem. The vertices of a triangle are 2, 1, minus 2, minus 2, 1, 0. Then the sum of squares of lengths of the medians of the triangle is sum of squares of lengths of the medians. If suppose ABC are vertices of a triangle, the given points consider A 2, 1, B minus 2, minus 2, C minus 1, 0, C 1, 0, C 1, 0. Now the lengths of the sides AB equals to, first length of the side AB equals to square root of 2 plus 2 whole square plus 1 plus 2 whole square, or that equals to, we get 5 units. Length of the side AB equals to 5. Next to length of the side BC equals to, length of the side BC equals to the distance between minus 2, minus 2 and 1, 0, or that equals to square root of 1 plus 2 whole square plus 0 plus 2 whole square, or that equals to root over 9 plus 4, that equals to root 13. Length of the side BC equals to root 13. Next to CA equals to the distance between 1, 0 and 2, 1, or that equals to square root of 2 minus 1 whole square plus 0 minus 1 whole square, or that equals to square root of 1 plus 1 root 2. Length of the side CA equals to root 2. Now if suppose AB, BC and CA are lengths of the sides of the triangle and DEF are middle points of the sides BC, CA and AB of the triangle ABC. Now required the sum of squares of the medians of the triangle. Now required AD square plus BE square plus CF square, AD square plus BE square plus CF square. Now 3 times to sum of squares of the sides, 3 into AB square plus BC square plus CA square equals to 4 times to sum of squares of its medians, 4 times to AD square plus BE square plus CF square. Now 3 into AB square equals to 25 plus BC square 13, CA square 2, that equals to 4 times to AD square plus BE square plus CF square. Now required sum of squares of the medians, AD square plus BE square plus CF square. Now that equals to, we get AD square plus BE square plus CF square equals to, here 3 into 25 plus 13 plus 2, 25 plus 13 plus 2, it completely equals to 40. 3 into 40 by 4, 3 into 40 by 4, or that equals to, we get 30. Option is third option. Next problem. The midpoints of the sides BC, CA and AB of the triangle ABC minus 1, 3, minus 2, 4, 2, minus 5, 2, minus 5. Then the length of the median through vertex A, the length of the median through vertex A, triangle ABC, Now given the midpoints of the sides BC, CA and AB of the triangle ABC. Now first point is midpoint of the side BC. Now BC midpoint consider D minus 1 comma 3. Midpoint of side CA E minus 2 comma 4. Midpoint of the side AB F 2 comma minus 5. 2 comma minus 5. Now required the length of the median through vertex A. Length of the median through vertex A means the distance between A and D. Required the length of the median AD. Now required the coordinates of the point A. Now the coordinates of the point A equals to sum of adjacent midpoints minus opposite midpoint. Now it is nothing but F plus E minus D. The coordinates of the point A equals to F plus E minus D, or that equals to 2 minus 2 minus of minus plus 1 comma minus 5 plus 4 minus 3, or that equals to 1 comma minus 4. The coordinates of the point A 1 comma minus 4. A coordinates 1 comma minus 4. Now required length of the median AD, or length of the median through the vertex A. It is nothing but AD. Now the distance between A and D equals to square root of 1 plus 1 whole square plus minus 4 minus 3 whole square, or that equals to square root of 4 plus 49, or that equals to root 53. Therefore the length of the median AD equals to root 53. Then option is second option. Now next problem. The length of the side of a triangle ABC, AB equals to 10, BC equals to 7 and CA equals to root 37. Then length of the median through the vertex C. Length of the median through the vertex C. Consider triangle ABC. ABC is the triangle. Length of the side AB equals to 10, BC equals to 7, CA equals to root 37. The lengths of the sides of the triangle ABC given. Now length of the side AB equals to 10, BC equals to 7 and CA equals to root 37. Now required the length of the median through the vertex C. Consider midpoint of BC is D. Required length of the side, length of the median CD. Length of the median CD. Length of the median CD. Now in triangle ABC, D is midpoint of AB, then CA square plus CB square equals to 2 times to AD square plus CD square. AD square plus CD square. Now here length of the side AB equals to 10, but D is midpoint of AB. D is the midpoint of AB. Then length AD equals to D is midpoint of AB. Then AD equals to 5 units. AD equals to 5. Now CA square equals to 37 plus CB square 49 equals to 2 times 2 AD square 25 plus CD square. Now require the value of CD. 37 plus 49 86 equals to 2 into 25 plus CD square. 43 equals to 25 plus CD square. Therefore CD square equals to 18, or for implies CD equals to root 18, or that equals to 3 root 2. Then length of the median CD equals to 3 root 2. Then first option First option is the answer. Next problem. The centroid of the triangle formed by the points P, Q, Q, R, R, S is origin 0, 0, 0, 0. Then require the value P cube plus Q cube plus R cube equals to. Now the vertices of the triangle given P, Q, Q, R, R, S and centroid of the triangle is origin. Require the value of P cube plus Q cube plus R cube. Now centroid of the triangle with given vertices equals to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Now that equals to, we get P plus Q plus R by 3, comma Q plus R plus, now Q plus R plus P by 3, but that equals to 0, 0 origin. Now equate x coordinates or y coordinates, we get P plus Q plus R equals to 0, P plus Q plus R equals to 0. Now P plus Q plus R equals to 0, we get P plus Q equals to minus R. Now cubing on both sides, we get P plus Q whole cube equals to minus R cube, or P cube plus Q cube plus 3PQ into P plus Q equals to minus R whole cube, that equals to minus R cube, minus R cube. Now P cube plus Q cube plus 3PQ into P plus Q equals to minus R, that equals to minus R cube. Now minus R cube take left side, therefore we get P cube plus Q cube plus R cube equals to 3PQR, 3PQR, 3PQR. Now option is second option. Next problem. The orthocenter of the triangle with vertices 2, 3, 2, 5, 4, 5. Required orthocenter of the triangle formed by the points 2, 3, 2, 5, 4, 5. Now the orthocenter of the triangle, if suppose consider triangle ABC, AD perpendicular to BC, AD perpendicular to BC, or AD is one of the altitude of the triangle. Similarly another altitude BE perpendicular to CA, third altitude CF. Now the three altitudes AD, BE and CF are concurrent at one point, then that point is called orthocenter of the triangle. Now the point of concurrency of altitudes of a triangle is called orthocenter. The point of concurrency of altitudes of a triangle is called orthocenter. If suppose taking a right angle triangle, if suppose PQR is a right angle triangle, PQR is a right angle triangle. Now required orthocenter of the right angle triangle, orthocenter of the right angle triangle. Suppose take the vertex K, vertex P. Now the opposite side for vertex P is QR, QR. Now PQ perpendicular to QR, then the side PQ is one of the altitude of the triangle PQR. The side PQ is one of the altitude of the triangle PQR. Similarly take the vertex R, take the vertex R. Now the opposite side for vertex R is PQ. Now RQ is perpendicular to PQ, then RQ is second altitude, RQ is second altitude, then Q is the point of intersection of altitudes. Therefore the orthocenter of the right angle triangle is its right angled vertex, then orthocenter of the right angle triangle is its right angled vertex. Now Q is orthocenter of the right angle triangle. Now observe the first 2 points. In first 2 points, x coordinates are equal. X coordinates are equal. Now in 2 points x coordinates are equal, then the line segment joining 2 points parallel to y axis. Take x axis and y axis. First point 2, 3. On x axis 2 units, y axis 3. First point 2, 3. Next point 2, 5. On x axis 2, y axis 5 units. 2, 5. Now in 2 points x coordinates are equal. X coordinates are equal. The line segment joining 2 points parallel to y axis. Parallel to y axis. Next third point 4, 5. On x axis 4, y axis 5. Point 4, 5. Now in 2 points y coordinates are equal. In 2 points y coordinates are equal, then the line segment joining 2 points parallel to x axis. One side parallel to y axis, other side parallel to x axis, then the points form a right angle triangle. The points form a right angle triangle. Then the orthocenter of the right angle triangle is its right angled vertex. Then answer 2, 5. Answer 2, 5. Option is third option. Next problem. The circumradius of the triangle with vertices 2a, 0, 2a, 2b and 0, 2b. Required circumradius of the triangle with vertices 2a, 0, 2a, 2b and 0, 2b. X axis, y axis. First point 2a, 0, it lies on the x axis. 2a, 0. Second point 2a, 2b. On x axis 2a, y axis 2b. 2a, 2b. Third point 0, 2b. 0, 2b. Now the given points form a right angle triangle. The given points form a right angle triangle. Suppose 2a, 0, consider a, point A, next B, C. Triangle ABC is a right angle triangle and its right angled vertex consider as C. If suppose a circle passes through 3 vertices of a right angle triangle, 3 vertices of a right angle triangle, then the hypotenuse of the right angle triangle, is the diameter of its circumcircle. Now circumradius equals to half of the diagonal of the right angle triangle. Now the length of the diagonal AB equals to the distance between the points 2a, 0 and 0, 2b, or that equals to square root of 4a square plus 4b square, or that equals to 2 into square root of a square plus b square. It is length of the diameter of the circumcircle, but required circumradius r equals to half of hypotenuse, or that equals to square root of a square plus b square. Now option is fourth option is correct.